like I said, Russian books are very, very interesting. They really go to expand your mind and think out of the box and make you think out of the box. Whoa! What is this? Y equals sine x power to x? How am I supposed to do that? Well, because the rule I recall was something like k xn prime is equal to kn x n minus 1, but the condition was that k and n were real numbers. This is a variable, so I don't think this works with this. In fact, it doesn't, right? So how am I supposed to deal with this, okay? Well, remember the previous video, right? Well, where we had with just a multiplication of 3 factors, and it looked like the method, the out-of-the-box method, wasn't really paying that off, and it looked more complicated than just simply doing the algebra involved doing the multiplication of the elements. Well, now is the time where that method really pays off, because this rule does not work for this function, okay? So, how are we going to attack this problem? Well, here's where the out-of-the-box method pays off. And like I said, in math, it's good to know other methods, okay? It helps you to attack maybe not the simplest problem, but when you see something that's slightly more complicated, slightly different, you know, something that you haven't seen before, well, maybe that method that I saw in that past video may help me, and indeed it does. We're going to use the properties again, okay? Not all of them, but in essence, you know which one we're going to use? This one, okay? A and B can be whatever. It can be functions, it can be whatever. I'm not placing any condition at all in the properties, as you can see. Okay, so it can be anything you can imagine. So, what I'm going to do is simply rearrange y and use natural logarithmics. Okay, I'm going to put the book down. There you go. Once I've been able to use natural logarithmics, a whole new world is going to be placed in front of me. Okay? So, I'm going to apply natural logarithmics to both sides of the equality. Okay? Natural logarithmic of y equals natural logarithmic of sin x power 2x. I think I have one more parenthesis than I should have. Yeah. Okay? Now, things look a little bit simpler to me because natural logarithmic of y equals, using this property right here, x natural logarithmic of sin x. Okay? All I did was use this little property right here. It's a natural logarithmic property, okay? Now, I can do the prime, and it's way easier for me. I got rid of the issue with the x and the exponent, okay? So I'm going to do prime on both sides of the equality. Okay? Again, what is the derivative of logarithmic of y? Remember, y here isn't the variable, it's the function, okay? The variable is still x, so the derivative of a natural logarithmic of y is going to be 1 over y times the internal derivative of y, which is y prime, okay? So this one goes away, and I just type in y prime equals. Here, I have the derivative of a product, as you can see, because I have x times logarithmic of sin, okay? So, here I'm forced to use the product rule. I have no other choice, okay? But it's going to be way, way easier, and we can do it real quick, okay? Derivative of the first function, let's do it in, let's do both colors just to keep consistent. Derivative of the first function, the first one being x, and the second one being logarithmic of sin x. Derivative of the first is 1. Derivative of x is 1 times second natural. So it's going to be logarithmic of sin x plus second function derivative. The second function is logarithmic of sin x. Derivative of logarithmic sin x is sin x goes in the denominator because it's 1 over sin x multiplied by the internal derivative. What is the internal derivative? The derivative of sin x. What is derivative of sin x? Cos. And all of this is multiplied by the first original function without its derivative. It's just natural. Okay? Now, remember high school? Trigonometry? What is cos over sin? What is cos over sin? It's another trigonometric function. It's cotangent. So cos over sin is cotangent. I'm just going to rephrase it as cotangent, okay? It makes no sense to have cos over sin right here. So I now have cotangent. There we go. Okay? It doesn't make sense to have 1 here, so I'm just going to erase it. There you go. Now things look nicer, eh? So, what's left here? Just organize, and that y over there on the left side of the equality, just bring it up here, and we'll be done. So let's do that. Y prime equals natural logarithmic of sin x plus x cotangent of x. I just rearranged these two. All of this multiplied by y. And what is y? This y. This y. So all of this goes right here. Sin of x power to x. And that is the solution to the problem. Quite interesting, quite fascinating. The out-of-the-box method now pays off, okay? Let's do it again one more time. Here's our function. Y equals sin of x. All of this, power to x. Whoa! I cannot use the exponent rule because the exponent rule states that the exponent has to be a real number. It cannot be a variable, okay? So what I did was apply natural logarithmic to both sides of the equality, okay? So on the left side I'm going to have natural logarithmic of y. On the right side I'm going to have natural logarithmic of sin x power to x. Using this property right here, okay, where a and b can be whatever, okay, there's no rule for that, the x goes down, so again I just rearrange. Logarithmic of y equals x goes down, x multiplies natural logarithmic of sin x. Now I do the prime, the derivative, and on the left side I'm going to have derivative of natural logarithmic of y. 1 over y multiplied by the internal derivative, y prime. Okay, remember that y is not the variable, it's just x the variable. Okay? And on the right side I'm going to have a product, which I resolve. Derivative of the first is 1, I erased it, multiplied by the second without its derivative, just natural plain logarithmic of sin x, plus derivative of the second, which is derivative of natural logarithmic of sin x, and that is 1 over sin x multiplied by the internal derivative, which is cos. But cos over sin is cotangent, so I just rephrase that to cotangent of x multiplied by the first original function, x. I just rearrange this, and then I move the y, which was dividing, now I pass it here multiply. And the result is this. Y prime equals natural logarithm of sin x plus x cotangent, which was this expression, multiplied by y, which is this expression. And that's it. That's the solution for the problem. Using the alternative method. Again, always think of this and use this when you have permission from your professor, okay? Show him the exercise and let him know what you think. Say something like, whoa, I went to this website called helpmegraduate.com and there's this person, this guy, who likes to tutor and do these videos. What do you think of this method? Can I use it in class? Can I use it in the exams and the quizzes and the assignments? Do you like it? Or do you prefer me to stick to the protocol? Or do you encourage me to follow these sort of alternative methods? Okay? Let him know what you think and keep practicing, okay? Like I said before, at the beginning of this video and at the end of the previous one, the alternative methods are intended for real complicated functions, for real, you know, those things that I can't nail them, they're too complicated for me. Whoa, what happens if I try something out of the box, something new, okay? And again, I'm not using anything that is extremely exquisite or complicated. I'm just using basic logarithmic properties and basic properties of chain rule with logarithmic functions. Thank you again. Visit our website, helpmegraduate.com.